Hey everyone, Jase Dussia here from Apex Aerotech. Today we have a really special video planned for you. This is a start to finish 120cc aircraft assembly featuring our 102-inch Slick 360. This is really a video that we've been wanting to do ever since the launch of Apex Aerotech and our decision to get into the 120cc market with a 102-inch Slick 360. The 102-inch Slick 360 is designed to embody an extremely wide flight envelope, all the way up to the most demanding flying, such as world-class freestyle competitions. Of course, included in that extremely wide flight envelope are stable and predictable tendencies that make for a very friendly aircraft. We are extremely proud of having the 102-inch Slick 360 as our first 120cc aircraft, as it really sets the bar for this size. You will see that the Slick has many pre-installed features, a lot of things included in the ARF kit to speed up the assembly process and make it more enjoyable. There are a lot of setup options that can be used on the 102-inch Slick. This video will cover my own personal equipment and electronics setup. Additionally, for those of you that are experienced with assembly of this aircraft, you may have your own procedures as well. This video is not to show a right or wrong, it's just to show our personal setup and our procedures for assembling this size of aircraft. So once again, we really appreciate you taking the time to tune into this video. We hope it is a very helpful resource for you. So without further ado, let's get right into it. Several features are included with the Apex Slick, including the extensions being pre-installed and the Aileron servo connectors being pre-installed. First, we'll gather the items to complete the landing gear assembly and the wheel installation. The landing gear installs with 4 bolts. They are typically already threaded into the aircraft in the blind nut, so we'll remove them. We'll apply blue Loctite. Then we'll thread them back in with the landing gear installed. Now we're ready to tighten them down. We'll locate the landing gear cuffs and slide them over the landing gear to ensure the proper fitment. Then we'll install our axles, again using blue Loctite. We'll thread the axle nut on. Now we can tighten the axle down with the main axle nut. This shows the axle installed vertically so that we can ensure that the wheel pant will fit on properly. Now we can slide our wheels over the axles. Again, we'll install blue Loctite over the end of the axle. Now we can install our collar nut on the outside of the wheel and tighten that down. Be mindful to not tighten it too much, as we want to allow the wheel to rotate easily. Now we can bolt on the wheel pants with the 2 bolts, again using blue Loctite. The axle and wheel pant include a built-in wheel pant saver system, where the axle is actually threaded at the end to receive this bolt. We have a removable rudder system, which includes one single hinge wire that slides through the hinges when aligned. There's a 90-degree bend on top and a collar at the bottom to hold the wire in place. The tailwheel installation includes a ball link that inserts at the bottom of the rudder. This portion is threaded. The tailwheel tiller wire will slide into this ball link, so we'll make sure that it is facing the direction of where the tailwheel will be mounted. The tailwheel installs using 2 bolts. The provisions are already located in the fuselage. Of course, we'll again apply blue Loctite to these bolts. The tailwheel contains a small set screw for the tiller wire. We'll slide the tiller wire in, and then we can bend it to ensure that it reaches the ball link for the tiller wire receptacle. Sometimes heat can be the easiest way to do this. The tiller wire does have a flat spot at the end. Be mindful of this, as this is to line up with that small set screw. We can install Loctite and tighten down the set screw against the tiller arm wire. After ensuring that the rudder moves freely with the tailwheel fully installed, we can cut off any excess length of the tiller wire if needed. To install the landing gear cuffs, we recommend a rubberized adhesive such as goop. We'll slide the cuff up and we'll place a piece of tape for marking where the bottom of the landing gear cuff is. Then we can slide the cuff back down, and this is an indication of where we can place 2 beads of goop, one on each side of the landing gear. Then we can slide the cuff back up and tape it into place. We'll want to make sure that the cuff is securely taped. One trick that you can do is take a piece of tape and press it against the seam of the landing gear and landing gear cuff. This will help make sure that no residual goop will drip down the landing gear leg. One thing that we recommend is to install Loctite on the ignition pickup sensor bolts. There's no need to adjust the pickup sensor. Simply remove one bolt at a time to install Loctite and reinstall. On the slick, we will be using the Apex and Dual Sky aluminum engine mount. The engine bolt holes are already pre-drilled. For this aircraft, we'll be installing the throttle servo inside the motor box on top. So here we are drilling a hole to allow for the linkage to pass through. This hole is to allow the ignition pickup wire to pass through the firewall. For this installation, we will be using the hardware that comes with the Apex Dual Sky aluminum engine mount. For the slick, we will install both Aileron spacers to bring the engine mount to 25mm spacing. Once the engine mount is seated against the firewall and the bolts are slid through, we'll install some fender washers against the back side of the firewall. Then we will install the smaller washers that come with the engine mount. We'll install Loctite on the threads of the engine bolts. Now we can thread on the nuts at the back of the engine bolts. To securely fasten the engine and the engine mount to the firewall, we will use an impact driver and a socket ratchet. To finalize, we can then go back and manually check the tightness of each engine bolt and nut. The aileron servo connectors and extensions are labeled L and R for left and right, and F and B for front and back. Front indicates inboard, back indicates outboard. You do not need an extension for the inboard aileron servo. The aileron servo setup for the 120cc slick includes 2 aileron servos per wing. The outboard will be hooked up to the provided extension. Be sure to install the provided grommets and eyelets for your servos. We will connect the outboard aileron servo extension. Shrink tubing or a servo safety clip is recommended. The control horns are already painted and pre-installed, and each servo bay has a servo arm orientation indicator. We can use the provided string that's already routed through the wing to guide the outboard aileron servo lead and extension through. We've removed the aileron servo arm orientation indicator and placed the servo into the bay. We'll initiate the threads of each servo screw first. The inboard aileron servo does not need an extension. Notice how we have each servo lead coming out of the pre-installed rubber grommet on the wing root. The outboard servo extension is labeled B for back. Now that we have created the threads for the servo screw holes, we can back them out and put a little bit of thin CA into those holes. This will help harden those threads to prevent any future stripping. Be sure to allow time for the CA to set up before reinstalling the servos. After doing so, we can tighten the servo screws back down. One helpful tool is a servo centering device to help center the servos before installing the servo arms. There are 2 types of ball links in the hardware. One that is symmetrical on both sides of the ball, and one that has a flanged end. The hardware also has built-in flanged washers on both the bolts and the nuts. The flange side of the ball link is to be installed against the servo arm. Here we are installing an aileron servo arm to the linkage at the 1.25 inch location of the servo arm. The apex slick is properly engineered to where the 1.25 inch location will give you your proper throws while maintaining high resolution, proper geometry, and mechanical advantage. We have used a servo centering tool to ensure the servo is centered, and we have installed the servo arm as close as possible to 90 degrees to the servo case. Now that we've done that, we will install the servo arm bolts. This is a clamping style servo arm, which is highly recommended for an aircraft of this size. We'll install the center bolt, of course using blue Loctite. Blue Loctite once again for the clamping bolt. Again, a look at the 1.25 inch mark on the servo arm. The elevator servo installation is very similar for the mounting itself. Again, a servo arm orientation indicator. Simply remove this before installing the servo. Once again, we've made sure that the servo is centered, and we've installed the servo arm 90 degrees to the servo casing. The flange side of the ball link is installed against the servo arm, and for the elevator linkage, we are installing it at the 1.75 location of the servo arm. The slick features a pre-installed and already mounted elevator servo lead connector inside the fuselage. To install the engine exhaust, we will use the clear cowl cutting template to mark where the exhaust holes need to be placed on the cowling. We can prepare this template by cutting out the back side as shown. With the cowling off, we'll take the template and line it up against the fuselage to make sure we have enough clearance. We also want to cut out the hole for the carburetor inlet in the cowling design. We can now take the template and line it up against the cowling. Let's locate the holes in the cowling for the cowling bolts. In accordance to those, we can now create holes in the template itself in the same location where the bolts install. Now we can directly mount the template onto the fuselage for accurate alignment. To install the exhaust, we have the muffler, of course, Permatex Ultra Copper RTV, red Loctite, and the gaskets. We'll install the Ultra Copper along the exhaust ports, not too heavy of a bead. We can then install the exhaust gasket. For the muffler bolts, we'll use red Loctite on the threads. If you do use an impact to install the mufflers, it's very important to use a driver extension as shown. This use of sandpaper is an easy way to give the mufflers a nice shine if you'd like to. One thing that we typically do is take about 3/4 of an inch off the end of the muffler. This can easily be done with a pipe cutter as shown. Doing this allows for easier removal and installation of the cowling, and you don't have to open up the exhaust holes of the cowling as much. There's no negative effect on performance. Now that the exhaust is mounted, we can place the clear cowl cutting template back onto the fuselage, bolt it down slightly, and make our initial markings. Now that we've marked on the template where the exhaust is, we'll cut these holes out. We can align the template back on the cowling and make markings on the cowling itself. One option that you can do is tape off the carburetor before cutting the cowling. This is due to the significant amount of fiberglass dust that is created in this process. We'll make the initial cuts into the cowling with a Dremel. Be aware that this does create a significant amount of fiberglass dust in the process. We can now begin test fitting with the cowling to the exhaust. This may take some slight adjustments with the Dremel until the fit is satisfactory. Once the cowling does fit on the aircraft with the exhaust installed, you can take a piece of sandpaper and clean the edges of the openings. 2 of the 4 total bolts that mount the cowling are located on the bottom. The Slick offers different fuselage hatch options to be installed on the bottom of the fuselage. These are recommended for any exhaust setup. Once we've located which hatch locations we'd like to use, we can begin to cut out the covering very carefully. If using an X-Acto knife, it's best to use a fresh blade for this process. We can now take a covering iron and seal down the edges. We'll ensure that the hatch fits properly. It's recommended to use a little bit of CA to strengthen the tabs before mounting the hatch. Of course, let the CA fully cure before placing the hatch back on. We can now use the provided screws and the hatch is fully secured. It's now time to set up our throttle linkage. This engine already had a ball installed on the carburetor arm, so for simplicity, we're simply removing the existing ball out of the control linkage that we will be using. We can now clamp the linkage onto the carburetor arm. For this setup, we will be installing the throttle servo inside the motor box. For the throttle servo, we will be using a 1.25 inch arm with the linkage installed at the 1 inch location. Speed and resolution are very important for the throttle servo. The goal is to have the servo arm close to 90 degrees to the servo casing when at half throttle. Regarding endpoints, we will want both numerical values of positive and negative to be fairly close to each other. I typically like to use an ignition switch that eliminates the need for an ignition battery, such as an Ibex or this JR-DA ignition kill switch. For items such as the ignition leads, we typically install some split sleeving to protect from any possible chafing. We are going to mount the ignition inside the motor box with the ignition wires coming out of the sides of the motor box through the pre-installed rubber grommets. First, we'll mount the ignition module using Velcro. We'll place the ignition switch right next to the ignition module using adhesion-backed Velcro as well. This hole is being drilled to allow a zip tie to pass through to further secure the JR-DA ignition kill switch. For the ignition module, as you can see, there are already provisions for the zip tie to run through. We'll use further zip ties to secure the wires running from the kill switch and ignition module. For the ignition pickup leads, of course, we'll make sure the polarity of the two connectors are correctly aligned. And we recommend installing a servo safety clip for added security in flight. The Apex Slick has a very conveniently placed pre-installed rubber grommet, so we can run the servo lead from the throttle servo through that and join it with the other leads from the ignition switch. We'll be installing one single rudder servo in the tail for push-pull. We'll be using a 2-inch aluminum clamping style arm, and just like the elevator, installed at the 1.75-inch location. After removing the servo arm orientation indicator, we will locate the pre-installed extension, which has clamps on both sides for added security of the servo connection. In order to access the extension from the tail, the extension is not pulled all the way through the guide tube, so there is a provided string so that after the servo is connected to the extension, we can then pull it all the way through. Notice for the rudder servo, we are installing the linkage on the underside of the servo arm for proper geometry. The end of the linkage that contains the symmetrical ball link will go inside the control horn, just like the rest. After creating the servo screw thread holes, we will apply some thin CA and let that cure. We'll use the provided turnbuckle wrench to mechanically center the control surface in relation to the servo arm still being 90 degrees to the servo casing. We will route the extensions for the throttle servo along with the extensions for the ignition switch. First, we'll apply heat shrink to the lead connections. We are going to group these three extensions together and split sleeve them for better protection. Everything that is to be installed to the receiver will be guided through the pre-installed rubber grommet. This shows our receiver mounting location. There are provisions in the structure for the mounting screws depending on which receiver you are using. The Spectrum Power Safe receiver comes with a push button switch that we will mount on the side of the fuselage. We will make sure the covering is fully seated down before cutting any holes. There is a round provision on the side of the fuselage that works well with the Spectrum push button switch. After tightening, you can apply a small bit of goop for added security. Now we will install the small ignition switch LED towards the front of the fuselage. Make sure the Dremel bit matches the size of the LED holder. It may be a good idea to add some goop to the connections of the ignition switch. We also do this for the ports on the receiver. And just like everything else, we'll use zip ties to secure the LED wire. Now we will install our speed fueler fuel dot. There is a provision on the side of the fuselage that has the exact dimensions of this fuel dot. While installing, you may want to make sure that the logo faces upright. It is recommended to remove this cap that contains the logo before flying. For radio setup and before binding, it's important that you set your radio up to correspond with the proper amount of servos that are in the aircraft. Here we set up for 4 total aileron servos, dual elevator and 1 rudder. We will also match the channel numbers on the receiver to the numbers in the receiver port assignment menu of the radio. You do have the option to customize your channel assignment. In our setup, Aileron 1 indicates inboard and Aileron 2 indicates outboard. As you may recall, with the markings of our aileron servo connectors and extensions, LF and RF indicate the 2 inboard aileron servos, and LB and RB indicate the 2 outboard aileron servos. The servo extensions that run from the aileron servo connectors to the receiver are also labeled, so we can use these, match up this info from our RX port assignment menu in our radio, and easily plug in each servo plug to the corresponding receiver port. For example, right aileron 1 would be labeled as RF aileron on the extension and aileron servo connector, and this would plug into channel number 2 based on our receiver port assignment. Left aileron 2, for example, would be labeled as LB aileron and would plug into channel number 7 based on the listing in the RX port assignment. For this setup with Spectrum, we will install 3 total satellites. Notice how the satellite wires are all sleeved. This provides protection against any chafing. We'll plug some batteries in to provide power to the receiver when hooking up the switch so that we can make sure it is working properly. We will be routing one of the satellites to the front of the aircraft near the motor box. We are going to use adhesion back Velcro to mount each satellite. We noticed that now is a good time to secure the ignition pickup wire against the engine mount. These are the locations of the 2 remaining satellites. Notice how all 3 are facing in different orientations. Just like everything else, we've used zip ties to secure these satellite wires. There are several provisions for the fuel vent dot along the bottom of the fuselage just in front of the landing gear. This fuel vent dot comes with 3 provided wood screws, which we'll use to install, and a plug cap for storage and transportation. Let's be sure that the covering is fully seated before making any cuts. The first step of the fuel tank prep is to install a plastic straw around the fuel line that's used for the pickup. This prevents it from being wrapped around itself in the tank during flight. Using tie wire is an option for any connection inside the fuel tank. This helps secure the fuel line to the clunk and the fuel tank cap. We will make sure that the rubber O-ring inside the tank cap is properly seated. We will install the tank on the tank tray just above the CG. In this instance, we will be installing 2 tanks, one for fuel and one for smoke, so they are both on each side. If just running fuel, you can install the fuel tank in the center of the tank tray. First, we will use strips of adhesive back Velcro to stick the tanks to the tray. Now we will use Velcro strapping to further secure the tanks. Note that we have used the tank tray slots to pass the Velcro strapping through and around the tanks. For the fuel vent line, we will be wrapping it around the top of the tank to prevent siphoning. There are plenty of holes available in this Apex slick to route our lines through for clean organization. This vent line will be guided to the bottom of the fuselage to our fuel vent dot. Cutting a small piece of fuel line and clamping it around the main line is a good idea to also secure any connections, such as this fuel vent dot, for example. There's a provision with a pre-installed rubber grommet near the fuel dot location to guide the fuel fill line. Once all the fuel lines are organized and ran through the provisional holes, we can use zip ties to keep them tied together and all organized. Now it's time to connect the pickup line to the carburetor. We will use zip ties to shorten the length of the elevator servo lead so that it doesn't move around too much. The pre-installed elevator servo connector makes for easy installation and removal of the horizontal stab. Here we have the quick release mechanisms, which simply slide up to lock into place. For elevator travel setup, the up and down elevator values do not need to match, but they do need to match for left and right. In this instance, we will be running 57 degrees elevator up and 54 down. Here we are using the measure level application in an iPhone. For all servo setup, it's a good idea to mechanically adjust the centering first before entering any subtrim. For this setup, we will max out rudder travel, but we will match both left and right as close as possible. Notice how the linkage is at an angle when centered. This will straighten when it moves full left and full right. As mentioned previously, we want the positive and negative numerical values of the throttle servo travel to be relatively close. Be mindful of the extents and movement direction of the carburetor butterfly when setting up the throttle servo. When setting up the Aileron servos, we're going to start with just the inboard servo. The outboard is disconnected. Mechanically adjust centering before adjusting any subtrim in your radio. For this setup, we're going to aim for 38 degrees up and 37 degrees down. These are obviously not maximum bevel-to-bevel throws, but any additional throws will actually create an aerodynamic air braking effect at high air speeds. So 38 degrees up and 37 degrees down will give you your maximum roll rate performance. When setting up the outboard aileron servo, the first step is to match the mechanical centering and subtrim to the inboard. We can test this by using the provided hardware. We will use a similar procedure to match the travels for both down and up aileron. Notice how we use the provided control horn bolt to test alignment. The next step is to verify the throws by placing our measure tool towards the outboard aileron servo to verify. It's important to cross-check once again between the inboard and outboard servos. Continue to adjust until both servos are matched without any binding. Once all is confirmed, we can now install our hardware for the outboard aileron servo control horn. It's also a good time to double check that all servo arm hardware is tight and installed with blue Loctite. To drill the prop and spinner, we will use the proper drill jig for our engine application, in this case, the DA120. Before drilling, we should confirm where we want our prop located for startup to ensure proper indexing. We will also want to confirm that the spinner cone can be mounted to the back plate and not interfere with the propeller. First, we will drill through the back side of the spinner backplate and propeller. Notice how we will not drill all the way through quite yet. As we transition to preparation of drilling the front of the propeller hub, notice how we do have one hole that is drilled all the way through for reference. We will place one propeller bolt in this hole to ensure proper alignment. Now we can completely finish drilling of the propeller hub. When mounting the propeller, first we will make sure that all bolts are slightly snug against the prop washer. We recommend using a torque wrench for prop bolts to ensure an even and secure tightness. We tighten our prop bolts to approximately 95 inch-pounds. Notice how we are tightening the prop bolts in a star pattern. We will use blue Loctite to install the spinner bolts, ensure that the provided washer is included, and be mindful to not over tighten. Before flying, it is highly recommended to take an iron with a sock or a provided cover and go over all seams and points in the covering. So to remove the canopy, we have two quick release mechanisms on each side of the fuselage. Right now they are in the lock position. They are spring loaded. So we'll take the handle here, we'll pull out, then we'll slide back. This one is now unlocked. We'll do the same thing for the remaining three. You can see the indentation and the cutout. So when the canopy's back on it and we want to lock it in place, we just slide this forward and we're good to go. All right, so the canopy off the aircraft, one thing I'd like to point out, this arrow indicator at the rear of the canopy indicates this is where you will lift when the canopy is unlocked. So when we want to remove it, from each side of the rear of the canopy, we'll lift up here and then slide backwards. This is because the slick has two aluminum dowel pins which slide into their receptacles in the fuselage. We'll take a look at the quick release mechanism for the horizontal stab. It's pretty much the same thing as the canopy. So right now it's locked in place. So to unlock it, we'll pull it out and slide it up. We have two carbon fiber tubes for the horizontal stab, a larger one aft and a smaller one in front to add anti-rotation. For the elevator servo, we have a pre-installed connector mounted inside the fuselage. On the top, there's a clamp that clamps over the servo lead. Let's get a better look at the pre-installed elevator servo connector. So to lock the horizontal stab back in place, now we're good to go. All right, so we have our wings mounted now, as shown by the locked quick release mechanisms. You can see this black tab is seated flush to the side of the fuselage framing. This black tab helps ensure that the canopy cannot be installed when the wing is unlocked. We have our labeled and pre-installed Aileron servo connectors now hooked up to the Aileron servos. As mentioned previously, the LB Aileron indicates left back or left outboard, and LF is left front or left inboard. You can tell here our labeled outboard Aileron servo extension is also labeled LB Aileron, and the LF is just simply our Aileron servo stock lead. So that's an easy indication between the two types of leads. Same thing for the right aileron. The extension running from these Aileron servo connectors to the receiver is also labeled accordingly, so it makes for quick setup in your radio. So I've unlocked this right wing. You can tell with the black tab sticking up outside the fuselage framing and the bolt coming from the wing root is no longer engaged. Slid the wing out slightly. We have our main wing tube and our aft wing tube, which is a bit smaller. This helps with anti-rotation. We have our two bolts. The Slick 360 has two quick release mechanisms for each wing. There's the other one and the front anti-rotation carbon fiber pin. All right, so that completes the full assembly of the 102-inch Slick 360. At this time, I'm going to talk a little bit about radio setup as well as maiden procedures so that you can have the best possible experience getting used to your aircraft. Here I have my radio. I personally run the Spektrum IX20 SE. I've run Spektrum for a long time. That's my personal preference. And as you have seen in the video, we have set the slick up with a 14-channel power safe receiver. So we did mention how important it is to make sure that the radio aligns with the servo setup of the aircraft. We did mention the dual aileron servo setup with 2 servos per wing, single per elevator and single for rudder for this 120cc application. So that was in the model setup menu for Spektrum under aircraft type. That's how we access those servo setup options. Additionally, in model setup, one thing that I typically do before I made an aircraft, it helps fine-tune the trims a little bit more. We go into trim setup under model setup. Again, this is for Spektrum. Other brands may vary a little bit. So we go into trim setup. Typically, you will see that the trim steps, the numerical value that is indicated next to each control surface, I believe typically stock is set at 5. So for my personal preference, my aileron, elevator, and rudder, I dial that down to 2. And what that does is it decreases the trim steps. So it allows you to get a little more better fine tuning out of your trims. Instead of going at increments of 5, it goes at increments of 2. And you don't have to do 2, you can do 3 or 4, depending on what you're comfortable with. For Spektrum, our timer setup is also in model setup. For timers, for a 120cc aircraft with a 34-ounce fuel tank, I typically fly around 8.5 to 9 minutes. If you're not familiar with this type of aircraft and you don't have experience flying with this size tank, you can start at 8 minutes. If you have a faster flying style, obviously you may burn more fuel, so I wouldn't recommend going up to 9 minutes. Me personally, I stick at 8.5, and if I have a more power-hungry flight with the fuel, I'm usually pretty low. So that's a safe point, the DA120 and a 34-ounce tank, approximately 8.5 minutes. All right, so moving to the model adjust menu. This is previously where we did our servo setup, which includes the sub trims and travels. Also in this menu, we have our dual rates and expo. So I'll talk a little bit about expo. It's very personal preference based. That's what I've told everyone. I've seen a lot of very talented, high-class pilots all over the exponential range on what they prefer. So that's a very personal preference-based topic. Typically, when we are running throws that are mentioned in this video, which we set up this 102-inch slick at high rates to extract its maximum performance, typically we recommend starting with about 60% expo. Now this is for Spektrum. Exponential does vary a little bit in feel for different radio brands, we have noticed. So with Spektrum, we recommend starting at 60% and dialing up or down from there. Personally, I run about 50% on all control surfaces. I do not run any flight modes. It's just one flight mode for all types of maneuvers. If you do run flight modes and you run a lower travel rate than what has been mentioned in this video, obviously the exponential numbers will vary for that as well, depending on your feel. So expo, that's what we recommend. For maiden flight, approximately 60% going off Spektrum feel, and you can adjust from there. All right, so also in the model adjust menu, we have the throttle curve option. Now personally, there's 2 functions that I use the throttle curve menu for. The first one is high and low idle. It is not needed, but it's recommended for more controllable landing situations. If you want to slow the airplane down a little better, get a more controllable idle for landing while not risking the possibility of the idle going too low during low speed maneuvers, low throttle setting maneuvers. So typically we have a high idle or a flying idle, and then we have a lower idle which dials that down a little bit more to prepare for better landings. Additionally, there's a throttle curve option. This is another thing that's personal preference, just like the high and low idle. That's also personal preference, but with the throttle curve option, this varies aircraft to aircraft depending on how your throttle linkage is set up, throttle servo setup is, the tune of your engine. There's a lot of variables. So the throttle curve is something that may be adjusted as the engine's breaking in, as you get used to the airplane, that sort of thing. I'm going to show you the current throttle curve that we have for this 102-inch slick. Spectrum radio, typically all of our throttle curves end up at a similar graph to this. All right, so we're going to go back to the model setup menu to cover another item. This references our ignition kill switch. So we'll go to the model setup menu and we're going to go to channel assign. We're going to open up channel assign and we will see two sub-menus, our channel input configuration and our RX port assignment. Now let's go to RX port assignment and we will see how our different control surfaces match with the receiver port numbers. So for the 102-inch Slick 360, our servo extensions are labeled. So we go into this menu and we can see the numbers accordingly, and it is also labeled on the receiver as well. Now we're going to go to our channel input configuration. We will see that in this case for our setup we have aux 5, port 10. This is where we have plugged in our ignition switch and we have assigned it to a switch that we like to use. For me, I've decided to use this momentary button on the Spectrum radio, also known as the bind button. That is called switch I. So under number 10, channel 10, aux 5, we have it assigned to switch I. And then we will go back to our monitor, and if everything is set up, we press that down and it goes to positive 100. We let go, it's at negative 100. Different Ibex setups may vary. This is for the JRDA ignition kill switch. For this kill switch, it is set up to where when the aircraft is first powered on, you'll see that the ignition LED indicating the ignition power is turned off. There's no light on the LED, and then we press down our ignition switch and it turns on. And then we can let go of the momentary, and from that point on, the ignition is on until we hold it back down again. Typically, when you want to shut the engine off, when it's on a momentary switch, such as this bind button, we need to hold the button down until the engine stops. We also have it set up to where if you accidentally tap the momentary button or switch, the ignition LED just flickers a little bit and comes right back on. Typically in this amount of time, it really doesn't risk your engine shutting off. You may hear it burble a little bit, hesitate, but typically it's nice to have to hold the button down in order to cut the engine off completely to make sure that you don't accidentally tap the button and kill it entirely. All right, so now that we've covered a few setup features on our radio, we will talk about our maiden flight procedure. Obviously with a gas aircraft, our first step is to make sure that the engine is running properly and safely tuned. As far as break-in goes, we typically recommend to start with the suggested carburetor settings per your engine manufacturer. For the DA120, I run Redline 40-to-1 oil, non-ethanol fuel, anywhere from 90 to 94 octane is recommended. This is the recommended setup for oil mixture and fuel from Desert Aircraft. For break-in, all the way through the life of the engine, we run 40-to-1 Redline. We do not change it for break-in. Our break-in flight procedure involves somewhat IMAX style flying. We make sure that the engine always has proper airflow through the cylinders. We don't slow the airplane down. We don't really do 3D flying quite yet. And we make sure that the throttle settings vary throughout the first 3 to 4 flights. The first 3 to 4 flights are very important for the long-term reliability, longevity, and performance of your engine. You'll definitely start to hear the engine come in a little bit, start to make a little more power, be more responsive on the throttle throughout these first 3 to 4 flights. So long up lines, long down lines, make sure you're getting plenty of cooling into the cylinders and this procedure will really set you up for a very powerful and reliable, long-lasting engine throughout its lifetime. During the maiden flight, of course, the first thing that you want to do is make sure that the aircraft is trimmed out. Then the second thing we'll do is check the center of gravity. There are a couple different tests that we can use to do this. The first that we recommend is a 45-degree upline test, where we pull the aircraft up to a 45-degree upline, we roll inverted, and we see how it responds. For me personally, I run a somewhat neutral CG. So once the aircraft rolls inverted at this angle, it will draw approximately 2 to 3 fuse lengths and then slowly taper off. When we do a straight and level inverted test, I like to breathe on the down elevator slightly. This is personal preference. Different people prefer a different CG feel. Some people like it hands-off inverted, and some people like to use significantly more down elevator to keep it level. These aircraft have a very wide CG range, so even if the CG is very far off from your liking, chances are that the aircraft won't be in risk and you can still get it safely back to the ground so that you can further adjust. Of course, before making any CG test, make sure that the aircraft is properly trimmed so that you are not getting any improper readings during these tests. The first thing that we do for knife edge coupling testing is obviously we roll the aircraft to knife edge. We apply rudder to hold it at knife edge and typically keep it at 1 throttle setting, just enough to maintain altitude and heading. And we test for pitch coupling. So personally, I will hold the aileron if there is any aileron coupling, and we'll test solely for pitch coupling. We will fine tune that in our radio, our mixing setup. So this is a mix that is rudder to aileron to elevator. So when testing for pitch coupling first, we will adjust our values, rudder to elevator. For a Spectrum radio, in the mixing menu, whichever way the rudder is pointed, left or right, that is the box for your corresponding numerical values for either pitch or roll. So we will adjust the pitch coupling first. Typically, if there is any coupling in an aircraft and everything is set up properly, the aircraft will push towards the landing gear on an aerobatic airplane and roll towards the landing gear as well. So once we have our pitch coupling sorted out and our mix placed in if needed, we will test for roll, and typically if the aircraft is set up properly, not all the time, but most of the time, it will roll towards the landing gear. There are a couple different ways that you can set up a knife edge mix. Some people prefer a curved mix where the amount varies based on the amount of rudder that is applied. Personally, I just use one linear mix, and there's no switch tied to it, and it is on at all times. So once you have gone through these procedures in flight, trimming, CG test, and then checking for knife edge coupling, pretty much the only priority is to make sure that the engine finishes its break-in process. So as a recap, first 3 to 4 flights, making sure that the engine gets plenty of airflow, and you'll hear it come in a little bit, start to make more power, and become more responsive on the throttle. You can also check and see if you wish to apply a throttle curve into your setup. Typically, once the engine is broken in and you start to do some low and slow 3D maneuvers, this is typically where you fine tune and see if you need a throttle curve, because these types of maneuvers are more demanding on throttle settings below half throttle. And once those items are all set up and adjusted to your personal preference, it's pretty much just fun and enjoying your aircraft from there. Of course, maintenance is a very important part of owning and flying a 120cc aircraft. We definitely recommend taking the time to clean the airplane after each use, each time at the field. This gives an opportunity to not only clean any exhaust residue off the aircraft or anything like that, but also go over every part of the aircraft to see if any bolts need tightening up. It's a good opportunity to check all seams and points in the covering. Every now and then it's a good idea to take an iron to the covering once again, freshly seat everything down in the seams and points to ensure that nothing comes off in flight. Of course, it's a good idea to take the time to check over every nut and bolt in the aircraft every once in a while, prop bolts, servo arm bolts, wheels and axles, you name it. It's all part of the maintenance process of a giant scale aircraft, and it'll definitely help maintain the longevity so that you can have it for many years to come. When cleaning, typically we use glass cleaner and paper towels for basic cleaning. This brand Sprayway seems to be pretty good for us. It's cleaned a lot of airplanes even after running smoke through it. For a more detailed shine, you can use a spray wax, and it gives a nice shine to both the covering and fiberglass parts. So that pretty much covers our video today for our 120cc assembly and setup video featuring the 102-inch Slick 360 from Apex Aerotech. We really appreciate you taking the time to watch this video. We really hope that it will benefit you in your setup and experience with this size of aircraft. Of course, any additional questions, feel free to reach out. Our Facebook group community, good resource, of course, info@apexaerotech.com, our website, apexaerotech.com. We have a good team of customer service, both in those resources, social media, you name it. So once again, we really appreciate you taking the time. We hope you enjoyed this video, and have fun with your 120cc aircraft.
Signature dead stick landing.